Hello and welcome to my YouTube channel. My name is Nenye Abraham and I will be your mathematics teacher for today. Now we have started a series of lessons on a topic calculus. Now in our first two lessons of the topic calculus, we did limits and introduction to calculus. In the previous lesson we have learned about limits and then we learned that limits can be solved in some particular forms. We have limits of polynomial functions, limit of rational functions. Now, in the last lesson, we solved some of the examples of limits of rational functions. And in this lesson, we shall continue with limits of rational functions, but we are going to solve more of the examples. And that we shall also learn what limits of infinity functions are after solving these questions. Okay, so without wasting much time, I will start solving the questions, and we have all learned so much that I wouldn't want to explain anything here. So please, if you haven't watched the introduction, you probably will have problems with solving these questions. And so I will encourage you to go to the previous video, then look at the introduction, and then also what limits of polynomial functions are. It will make this lesson very easy for you to understand, or these questions very easy for you to be able to solve. Now we are taking the first question. Solution. Lim 8x plus 9x all over x squared minus 9, where x is approaching 0. Now you realize that when we substitute 0 into this function, you realize that everything goes to what? 0, which is undefined. The numerator will become 0, the denominator will become 0, which will become undefined. When you substitute, this is what you get when you substitute straight. Now, which is undefined, so this is not undefined. We can solve it some other way to get the right answer. So what we do is we are going to manipulate the function, and then after our manipulations we substitute the limits inside. So what we are doing is that we will first factorize x out, because from the numerator, and then in the denominator the x is already factorized. Now if you factorize, you have lim x, where x is approaching 0. If you factorize x out, you are going to get 8. Okay, so I realize that this is not a question I want. This is a question I want. I've just created the questions on my own. So I wanted to add x squared here. So I've added x squared. So it is what? 9x squared. Now when you factorize what? X out of the numerator, you are going to get 8 plus 9x all over x squared minus 9. Now our x can cancel out x, and then we'll have limit where x approaches 0, 8 plus 9x all over x squared minus 9. Now here we can now substitute. because when we substitute, we are not going to get 0 over 0. So if you substitute, you are going to get 8 plus 9 multiplied by 0 all over 0 square minus 9. And this will give us what? 8 over 9. So our answer is minus 8 over 9 for the what? The first question of example 1. Now let's go to the second question. The second question says that lim x, where x is approaching 0, 2x cube minus 3x squared plus 4x all over x 5x squared plus 2x minus 3. Now the same thing happens here if you factorize, or if you substitute straight 0 in place of x in the question. You realize that the question will be 0 over 0, which we don't want it that way. So what we do is that we factorize x out of the numerator. If you factorize x out of the numerator, you get lim where x is approaching 0, x out to be 2x squared minus 3x plus 4 all over 5x squared plus 2x minus 3. This is equal to, substitute, so you realize that x will cancel x, and then we'll have now lim where x is approaching 0, 2x squared minus 3x plus 4 all over 5x squared plus 2x minus 3, and this is equal to 2 square minus 3 times 0 plus 4 all over 5 times 0 square plus 2 times 0 minus 3, and this will give us minus 4 over 3. That happens to be our answer. So let's continue with the example 2a. Example 2a. I decided to test us on a level on SATs. And please, if you don't understand what SATs is, the first topic I did is SATs. So you can go back to look at what SATs are, more especially rationalization of SATs. Rationalization of SATs. Go and search, you see the topic. Now, we are solving this. So we all know that when you are having a question like this, what you do is that to rationalize the function, you multiply both the numerator and the denominator by its conjugate. So we have lim where x is approaching 16 minus x multiplied by its conjugate will be 4 plus root of what? X all over 4 minus root of x multiply by 4 plus root of x. So we have multiplied both the numerator and the denominator by the conjugate, and this is what we have. So continuing, we'll be having lim x where it approaches 16, 16 minus x, 4 plus root of x, all over, then the denominator becomes difference of two squares. You pick the term with the negative side, square both terms, and then root of x also squared, and this will give us 16 minus x, 4 plus root of x, all over 16 minus x, because this will cancel out this. Now it will now be lim where x approaches 16, 16 minus x, 4 plus root of x, all over 16 minus x. So this is what 60 minus x, 60 minus x. This can take away this, and we'll now have lim x where 16, 4 plus what, root of x. Now I told you that we are just manipulating the function to get the basic form or the simplest one, and then we'll substitute it inside. If you substitute from here, if we would have substituted, everything would have been 0 over 0, which would be wrong. So we knew that. So I decided to cancel this out before our substitute. So right now we can now substitute, and then when we substitute, you will have 4 plus root of what, 16, which is equals to 4 plus 4, it is equals to 8, and 8 happens to be our answer. Now the next question I'm giving to you as trial. Next question, lim x 9 minus x square all over 4 minus root of x square plus 7. Please, this is your trial. Try this one. Now if you try it, pause the video and try it. Pause the video and try this. Pause the video and try it. So please, if you did it well, you are going to get 8 as your answer. The answer is 8. 8 will be the answer for the trial question. 8 will be the answer. Now let's continue our lessons with infinity. Limits of what? Infinity. How do we solve it, and what is the meaning of what? Limits of infinity. Now rational functions, f of x equal to this. Now we've learned about rational functions in our first video, so please, if you don't understand, go back to look at rational function. This was the previous video. This was what we did. So this is a rational function. Limit as x approaches infinity is written as, is just the same as what we have been doing. Limit of rational function f of x as x approaches what? Infinity. The limiting values of infinity can be determined by dividing through both the numerator and the denominator by the variable with the highest power of x. Now, the long and short of the whole story here is, if you are having a function f of x equal to x cube plus 2, then x raised to the power 4 plus 5. What is the variable here? The variable is x. Now, which of the x have the highest power? It is x raised to the power 4. So you divide both the numerator and the denominator, each term of both the numerator and the denominator, by the what? The variable with the highest what? Power. That is all what this thing is saying. Now, we are looking at some of the examples of limits of infinity, limits to infinity, some examples. Now, evaluate the following limits. Evaluate the following limits and then solution. Let's solution. A, lim where x is approaching infinity, 2x square minus 3x all over 3x square minus 2. And we said that when you are being given a question like this, look for a variable with the highest what? Power. With the highest power. Now, it is x squared that's having the highest power here. So we divide everything by x squared. The reason why we do that is, if you substitute this thing inside, you are going to get infinity. Did I say undefined? It will be undefined and you can solve it. That is why you have to manipulate the function before you substitute. So when we manipulate it, it will be 2x square over x square minus 3x over x square all over 3x square all over x square minus 2 all over x square. This is what you would do. Now, if you solve this, you're going to have, this will cancel out this. You're going to have 2 minus, this will cancel out this. It will be 3 over x all over, this will take away this, 3 minus 2 over x square. Now, this therefore implies that limit as x approaches infinity of 2 minus 3 over x all over 3 minus 2 over x square. Now you can now substitute your infinity inside. When you substitute it inside, you're going to get 2 minus 3 over infinity all over 3 minus 2 over infinity square. Now, where you see infinity, it is 0. So it will be what? 2 over 3. 2 over 3 is your answer, because this is 0, this is also 0. And you get what? 2 over 3 as your answer. Now let's continue our solutions. The next question is B is lim where x is approaching infinity, where x is approaching infinity, where x is approaching infinity. 4x cube minus 5x squared all over 2x cube minus x. So just like in the first question, the variable with the highest power is what? Is x cube. So lim x, where x is approaching infinity, 4x cube over x cube minus 5x squared over x cube all over 2x cube over x cube, then minus x over x cube. So this is equal to lim where x is approaching infinity. This will take away this. 2 of this will take away this. Then this will take away this. This will take away one of this. So it will be 4 minus 5 over x all over 2 minus 1 over x squared. Now you can now substitute inside. It will be 4 minus 5 over infinity all over 2 minus 1 over infinity square, which is equal to 4 over 2, and the answer is equal to what? 2. The answer is equal to 2. So 2 is our answer. Now let's go to example C. Example C. Example C. C is giving us lim where x is approaching infinity, 5x all over x plus 2. Now it will be lim where x is approaching infinity, 5x over x all over x plus 2 over x, and this will be lim where x approaches infinity, 5 over 1 plus 2 over x. Substitute inside, you're going to get 1 plus 2 over infinity, which is equal to what? 5 over 1. Our answer is what? 5. The last example, I'm tempted to give it to you as trial. I'm tempted to give it to you as trial. So D, we have lim where x approaches infinity, x cube minus 1 all over x minus 1. This is equal to same thing, lim where x approaches infinity, x cube over x cube minus so I realized something which I didn't see before. So in this question, this becomes an improper, fraction, and you have to change it to improper by using in our primary what we call long division by the quotient rule to divide it. We also call it long division. So not to waste much time there, let me do the long division. I'll probably not solve it after that's the long division. So x cube minus 1, x minus 1. So which value will you multiply by x to get x cube, x square? If you multiply x square by x cube, you are going to get what? X cube minus x square. And then if you are subtracting this, it will be 0. X cube minus x cube, it will be 0. Now there is some 0 x square here which didn't appear. There's some 0 x square which didn't appear. So it will be 0 minus x square. So it will be plus x square, then plus 1. Which value will you multiply by x to get x square? It is x. When you multiply it, you get x square minus x. When you divide, you subtract this, you are going to get 0 plus x. The same thing, there is some 0x here which didn't appear. So if you subtract 0 minus x, you get positive. Then minus 1. So which value will you multiply by x to get what? To get x here, it is 1 plus 1. So plus 1. 1 multiplied by this, you get what? X. 1 multiplied by this, you get minus 1. And so this will be what? This will be 0, 0 when you do your subtraction. So it means that when we divide x minus x cube minus 1 all over x minus 1, we will get x square plus x plus 1. So having limit where x is approaching infinity of x cube minus 1 all over x minus 1, it can now be written as limit where x approaches infinity of what? X square plus x plus 1. This. And when we substitute infinity inside that equation, it will be what? X square plus x, which is infinity, plus 1. Now this will give us 0, 0 plus this will give us 1. This infinity, this is infinity, so this will give us 1 plus infinity plus infinity. Infinity plus infinity, infinity square, something so many. If you add so many again, it will be so many. You understand? And then the answer will be so many, infinity. So infinity plus infinity square, something is so big. You still add something so big, it will be so big. Plus 1, it will still be big. Whether minus 1 or plus 1, it will still be big. Alright, thank you very much for watching my tutorial video. The name again is Inanye Abraham. and I've been your mathematics teacher. Please follow and do subscribe to my channel. Please always be the best moderator. I'm only moderating, I'm not teaching. Directing you how to do it. We are doing it together. Please turn on your notification bell whenever I release a new video. You can be able to watch. Thank you very much.